I will explain about the integrated circuit. An integrated circuit, sometimes called a chip or microchip, is a semiconductor wafer on which thousands or millions of tiny resistors, capacitors, and transistors are fabricated. The second is I will explain about the comparison between integrated circuit and discrete circuit. I will comparison of IC and discrete circuit. IC can be worked on low voltage. They can handle limited amount of power. They are very small in size. They are cheaper. Compared circuit on chip may be used to obtain improvement performance character. Discrete circuit requires competitive more voltage. Discrete circuit can handle much power than IC. Circuit which are discrete component require large space. Discrete circuit are costly than IC. The performance is not good. Next is I will explain about the application of integrated circuit, or in the short form IC. Application of IC. IC found numerous applications from car, automotive control, television, computer, microwave, portable device like laptop, MP3, PlayStation, camera, cell phone, to ship equipment, AEO, aeroplanes, spacecraft. They are also used in switching telephone circuit and data processing. They also found application in military equipment. The most component application in IC is digital watch, which tell hour, second, minute, day, and time. And finally, I will explain about the advantage using IC circuit over distracted component. The advantage of integrated circuit: it's very small size. Laser white means a larger number of components can be packaged into a single chip and weight reduce cost. The mass production technique has helped to reduce the price. High reliable due to absence of soldered connection, few interconnection, and small temperature rise. Failure rate is low. Low power requirement. As the size smaller, power consumption is less. Easy replacement.
Hello guys, today I will present about the function of IC packages. In electronics manufacturing, integrated circuit packaging is the final stage of semiconductor device fabrication, in which the tiny block of semiconducting material is encapsulated in a supporting case that prevents physical damage and corrosion. The case, known as a package, supports the electrical contacts which connect the device to a circuit board. The integrated circuit package is responsible for keeping the chip safe from all sorts of potential damage. Next is plastic or ceramic packages. The material used for the body of the package are typically either plastic or ceramic. They both can offer a high thermal conductivity and decent mechanical strength. Ceramic generally has more preferable characteristics, but is more expensive. Inexpensive plastic package can dissipate heat up to 2 watts, which is sufficient for many simple applications. Thus, a similar ceramic package can dissipate up to 50 watts in the same scenario. Lastly, I will present about SMT and THT. SMT, surface mount packages, range in size from small to minuscule. They are all designed to sit on one side of a circuit board and be soldered to the surface. The pins of a SMD package either extrude out the side, perpendicular to the chip, or are sometimes arranged in a matrix on the bottom of the chip. ICs in this form factor are not very hand assembly friendly. They usually require special tools to aid in the process. THT is Through Hole technology, uses holes drilled through the PCB for mounting the components. The component has leads that are soldered to pads on the PCB to electrically and mechanically connect them to the PCB.
Next, I will explain about scale of integration. The number of components fit into a standard size IC represents its integration scale. In other words, it's a density of components. In the early days of simple integrated circuit, the technology large-scale limit each chip to only a few transistors, and the low degree of integration mean the design process was relatively simple. Manufacturing yield were also quite low by today's standard. As the technology progressed, millions then billions of transistors could be placed on one chip, and good design required thorough planning, giving rise to the field of electronic design automation or EDA. Next, I will talk about Moore's law. In 1965, Gordon Moore predicted that the number of transistors that can be integrated on a die will double every 18 to 24 months, grow exponentially with time. Computing chip performance double every couple of years or 18 to 24 months. Amazingly visionary, million transistor chip barrier was crossed in the 1980s. And the last one is yield. Once the front-end process has been complete, the semiconductor devices are subject to a variety of electrical tests to determine if they function properly. The proportion of device on the water found to perform properly is referred to as the yield. Manufacturers are typically secretive about the yield, but it can be as low as 30%. This is example of this is formula how to find yield and dice per watt wafer.
Hybrid or multi-chip integrated circuit. As the name suggests, the circuit is fabricated by interconnecting a number of individual chips. Hybrid IC are mostly used for high-power audio amplifier application from 5 watts to more than 15 watts. The active components are diffuser, transistor, or diode. The passive component may be group of diffuser, resistor, or capacitor on a single chip, or they may be thin film component. The last one is interconnection between the individual chip is made by wiring process or a metallized pattern. The last subtopic, I want to explain the thin and thick film integrated circuit. Thick and thin film IC are comparatively large than monolithic IC and smaller than discrete circuit. They find their use in high power application. Thus it is a little large in size. This IC cannot be integrated with transistor and diode. Such devices have to be externally connected on to its corresponding pin. Passive components like resistor and capacitor can be integrated. The last is true, both the IC have similar appearance properties and general characteristics. The main difference between the two of them is the manner in which the film is deposited on the IC.